Okay, able to see the screen?
Yes, sir.
Yeah. So, see, what is this coordination margin? What is coordination margin? Anybody can tell? Mr. Pinaki, what is coordination margin?
It is the gap in time between the equipment you want to protect and the relay operating time. Like the curve of the relay and the curve of the equipment. That time gap is your coordination margin.
Okay.
I think.
Anybody? Okay. Okay. That is good. And Mr.
Yeah.
Inamal, what is coordination margin?
Coordination margin, I think coordination, the time gap depend difference between two relay, say
Two
downstream relay and the upstream relay.
Okay. Okay, sir, correct. Suppose, see, here you are able to see the single line diagram.
Yes, sir.
This is this incomer and this is the outgoing. Outgoing feeder, there is a fault, let's say 4.95 kiloamps. When this fault is there, first this breaker has to open. After that, this breaker has to open, right? That is backup protection. Now what? Now between these two breaker operation, I have to give a. I deliberately have to set some delay. Otherwise, if there is a fault, both the relay if they operate same time, what will happen? Okay, this is okay. But if this will operate, incomer, entire your power, to the entire factory, the facility is gone, right? So what I do in this incomer, I will set a deliberate delay. Now this delay is called coordination margin, okay? That coordination margin, the delay can be 200 milliseconds, can be 100 milliseconds, can be 50 milliseconds. Okay.
Sir, is it multiplication of 50 milliseconds?
No, no, sir, nothing like that. It is, some people give 250, some people give 150. Nothing like multiple of 50. It is a practice people have come across. Different utilities have different. This. That is a practice people have evolved. There is no standard. Mr. Loganathan, sir.
Yes, sir. Morning, sir.
Good morning, sir. The coordination margin, any typical figures you have come across?
No worries, I think clear about that. I think that's the time delay adjusted between the two breakers.
Yeah. So, what is the typical figure you have come across?
The difference in the settings.
This coordination margin, this type, any typical figure you have come across during your this one engineering?
I think whatever is there, I think I've come across all these numbers, 200
Oh,
millisecond.
okay.
Yeah.
Okay, sir. Okay. And our Naveen Kumar.
Sir.
Yeah, you have been doing a lot of relay settings also. What are the coordination margin you came across?
It's generally depending upon the panel, how many panels in between the load.
Yeah.
Generally 60 milliseconds.
60 milliseconds. Okay, okay.
Yes.
Okay. Mr. Vijay Renu, Vijay ji.
Yeah, what I'm seeing on the screen. Yeah, similar to that.
Okay, sir.
But in BS7671, the total time to flip, I think it says around 1 second or something. When we do this time.
Okay. So total should be one.
Yeah,
1
total
second.
should be 1 second. 1 second. Yeah. From
Okay.
transformer secondary to the final.
Transformer secondary to the
Final node.
final. Okay. After adding all those.
All, yeah.
Okay, sir. Okay. Okay, so see the coordination margin during your relay coordination. Please select whatever the owner specification is used. Suppose you are doing a shell project, you are maybe doing a total project, you may be doing some other NTPC project. Whichever project you are doing, please check what is the owner spec and you select. If owner is not giving anything, then you decide what is the type of relay. Relay is still old electromechanical or a electronic relay or a microprocessor based relay. You please check the type of relay. If it is, don't keep very less coordination margin. Don't keep very high also. Go for 100 millisecond or something. Okay. Now, how this coordination margin is arrived, you have to know. Like first, our Mr. Pinaki told one answer that the time required to operate, the time the relay gives a signal to the time breaker open. He told that. Okay. Now, what is that time? See, as soon as I tell you to do something, immediately, if I ask you a question, immediately you cannot answer. You have to think and you have to answer. It takes some time, right? Same way, as soon as our relay sees the fault current, breaker will not open immediately, right? So there is a time involved. What are the time involved? Number one, current has to flow through CT. From CT, it has to go to relay. Relay has to process. After relay do process, relay has to give a trip signal to the breaker. Breaker has to open physically. After breaker contact open, there is something called arc quenching, right? There is an arc. That arc has to completely quench. So all this will take some time. You add all this time, then you get the coordination margin. Okay. Now let us see some typical. Able to see this? Let me open the link. Mr. Krishna Kumar.
Yes, sir.
Yes, sir. Why, sir? You joined late. Yes, sir. Why, sir? You joined.
Sorry, sir. I slept just before I wake up.
Okay, sir. Okay, no problem, sir. Okay. Okay, fine.
Here time is 5:30, sir. That 1.5
Oh,
before.
correct. You are in. Yeah, you told me other day. I remember.
So,
Okay. You able to see the screen? Are able to see the ABV breaker?
yes, sir.
Are able to see? Yeah. See, this is our ABV breaker, vacuum circuit breaker, 11 kV breakers. Now you see here, if you go to the data sheet of this breaker, you will see the opening time. See, opening time, the time taken for the breaker to open is 33 to 60 milliseconds. Then after the breaker open, there will be arcing. That arcing is 10 to 15 seconds. Okay. So he's adding both opening time and arcing time and giving the total breaking time. So the total breaking time is 43 to 75 milliseconds. So actually speaking, when you are doing your relay coordination and selecting coordination margin, you can actually cross-check once what is the breaker at the site. Suppose you are doing a project for a old project, renovation project, and your breaker is a old, let's say, railroad make relay, railroad make breakers. So then what you have to do, you have to get the data of that breaker, okay? So blindly don't do relay coordination and do some coordination marking, okay? Please check what is the make of the breaker. Go through the breaker data sheet and see what is the breaker total breaking time, not just the opening time. Because opening time, you have to add the arcing time, then you get the total breaking time, okay? So 75 millisecond is the total breaking.
So here is another data, like
Yes, sir.
duty operating sequence.
That operating sequence is actually, this is the sequence given by the IEC for testing the breaker, sir. So when you are buying the breaker, you are telling the vendor that you have to supply me a breaker which will prove that it will operate in this sequence. And he will actually conduct a test. We will open, wait for 0.3 second, again close open, wait for 50 second, again close open. So this is that test. And after they do the test, it is like proving that my breaker is capable of this frequent opening close. Okay, sir?
Sir, one doubt, sir. Just
Yes, sir.
when I was joined, you were showing that CT sensing time normally how much it will be, sir?
Sir, see, basically what I am trying to tell is, if I have to give a coordination margin between these two, right? If there is a fault here, this will operate. Actually, I don't want this to operate immediately. Because of, so I have to deliberately give some delay. That coordination margin, I am telling it is sum of breaker opening time, relay, the operating time, and the CT actually, if you see CT does not take much time because it is like a transformer. Whatever comes in the primary, it will come in the secondary almost instantaneously. Only thing, because of the inductance, there is a small phase shift, and that if you see the CT error, in CT you have two types of error. One is your this one, what is that magnitude error? One more is the phase shift error. If you see that phase shift error, that is very small. And that phase shift error will tell you what is the time taken delay. And that is very small and that can be ignored. Okay. That is why I wrote it cannot be quantified. Because it is like it is a analog, this one. Whatever comes the primary comes in the secondary. Clear?
So this coordination margin is fixed irrespective of the type of earthing that you provide?
No, sir. Coordination margin is, when you say fixed for a project, if you're, let's say you're doing project for Shell, then you are fixed, and particularly for this site, let's say in Nigeria, you're doing the project and they're having all ABB breakers. Okay, you fix this margin. Now you are doing one more project where you are having all some old G breaker, then you please increase the coordination margin. Okay. So as a relay engineer, but for one plant, don't keep changing the coordination margin. Now let us say for this entire plant, one particular place I'm doing for BP Texas refinery, I'm doing coordination study. The entire plant has almost the same type of relay. So there you fix the coordination margin and you follow it. Don't change it. Okay, clear, sir?
Yes.
Okay. So the coordination margin, yes, sir.
So that will also depend on the number of levels also, no? Number of breakers in that whole sequence.
Yes, number of level, number of breaker will depend. But first we are choosing the margin. First and the foremost coordination margin, normally the owner is giving, we are taking. And as the number of level increases, you have to reduce the coordination margin
Reduce.
sometime. But I will tell you, you fix the coordination margin in the beginning of the project itself. Okay. And that, if the number of level increases and I cannot go for 50 millisecond if I'm having a vacuum circuit breaker. Okay. Just because the number of level is more, I can't blindly reduce my coordination margin because the vacuum circuit breaker, I told you previously, breaker itself is taking 75 millisecond. If I add relay operation 10 millisecond, 85, I have to give some more margin. I have to go for 100 millisecond. Though the number of level is very high, I can't go for 50 milliseconds. In such case, what you have to do, time coordination alone will not work. That time you have to go for interlocking or some signal based protection. So you have to do something that time. Sometimes.
Start building. Sorry. Okay. Sorry.
Yes, sir.
So my query was, won't you start first with the equipment curve and then go on to the relay, and then from the relay you create a gap between the equipment and the equipment to give the equipment, because in the previous class you had given us one exercise to do, which is that incomer and the motor pickup, to give the current pickup. Now, the equipment can also have a service factor, no, sir? It can withstand some amount of overload for a short duration of time.
Yes.
So in which time, like say if you have a motor, it has a service factor of 50%, it can take a 50% overload, even a transformer, for some amount of time. So in that amount of time, the relay should not operate. Only if it crosses that, the relay should operate. So that coordination, it starts with that, and then it goes on from upstream, right till the first breaker, primary breaker after your utility, right, sir?
Correct. You are correct. That is how we are doing the coordination. You are correct. But what is your query?
Is that when you put coordination margin, you start with the equipment.
No. See, don't mix up. See, I am okay. We'll do one thing. Pinakiji, I will not answer your question now. Okay. When we complete this exercise, your question will get answered. Okay. Instead of explaining, when we do all this exercise, whatever your question is there, you will understand. If you're still not understood, then I will answer. Okay. Is it okay? Huh? Yeah. Because practically, I will show you whatever your question is there, that will get answered for. Huh? Okay. So now we'll stop. We'll start again. When we start again, I will tell you the basic of curve plotting in Excel. Okay.